On this video, we're going to finish up this, I think, 3-video series about linked lists and stacking queues. I think now it's time for us to start implementing stacks and queues, right? Well, so that's what we're gonna do now. First, we're going to, let's say I'm going to create a new file here. And I'll create a file called stack. Let's create a stack first, and then we'll create a queue. Stack.java. So I think the first thing you have to do is to create what is called an interface. So interfaces are a collection of methods that need to be implemented by another class. What I mean by that is that the interfaces that do not implement the methods within it. They just lay out the methods that need to be implemented by another class. So in this case, we'll have to create a public interface. We'll call this stack. And the stack, we will use generics again. And what are the methods of a stack? Well, first we have to understand what stacks are. And I'll have an image here just for you to understand. Again, the concepts are simple, and of course they could become way more complicated depending on the kind of implementation you do. But here we're gonna keep things simple, and I'm just going to present to you a basic understanding of stacks. And if you want to understand more, if you want to dig a little bit deeper, you can of course just can find more information on books or even here on YouTube. A stack is a data structure that it's what it's called a last in first out. That means that the last element that you add to a stack is the first one to get out. So in this example, I push an element A into the stack, and then I push B, and then I push C, and then when I remove the element from the stack, the last element that was added is the one that is removed. So it's like a stack of books, for instance. That's why it's called stack. And imagine a lot of books stacked on top of each other, and then if you want to remove the last book, the move that you have to remove is the one that you added last, right? So that's exactly the case. If you add A, B, C, if you give a pop, if you use the pop method, C will be removed, and then if you push D, you push D on top of B, and then you pop, it will pop D, then B, then A, and so on and so forth. So we saw here a couple of methods that are used in a stack, and of course these are push and pop. So let's add them in the interface. First, of course, we have to add the public push, and if you want to push it into the stack, we have to give it a value t and then a value, and push. What's going to happen? Nothing, so it's void. Next method, and you can pretty much see that I'm just laying out the methods on the interface, but the interface itself does not implement any of them. We have to use another class which implements the interface stack, and we will do that in a moment. The next method we're going to use is the pop method. Now pop, when you remove a value, you want to return the value that you removed, of course. So t pop, and I'm gonna bring up the image again, not this one. If you want to take a look at the upmost value here in the stack, we can do that by creating a method called top, I think. I'll call it top. It will it will return the upmost value on the stack. And then of course you can add a method called size, just to get the size of the stack, and then you can create a method called isEmpty, just like we did in the linked list. Well, these are the common methods in a stack, and since the interface does not implement any of them, we have to create another class to implement this one. So yeah, let's do this. We will create a file called stack LinkedListStack.java, and in this class we will of course use linked list. We will use a linked list to implement it. Now we will start by using class, of course, then LinkedListStack with a type T using generics again. And let's take a look at the image again. A stack. Of course, you have to add things into the stack. You have to remove it from the stack. And this is from the last video I did. It's always better for us to draw things in so that we can understand it better. Well, again, so a stack, you can pretty much say that if you push something into a stack, you add it here, like an A, and if you push again a B, you'll have an A here and a B there on top of it, just like stacking books on top of each other. And then when you do this, you start to realize that, well, this looks really like a linked list, right? If you say that, for instance, imagine I have an empty stack, and then I push A into it. So A will be the first element in our linked list. And what if I add B? I push B into the stack. B, we add it in the beginning of our linked list, right? It becomes like this. What if I add C? What if I push C into the stack? It will go into the beginning of the linked list, C, B, A. Now, if I wanted to pop the upmost value in the stack, that simply means that I needed to remove the first element in our linked list. So then I remove, if I pop the stack, I just remove the first element in the linked list, and then become B, A. But if I wanted to add again, to push another value into the stack, I just added in the beginning. If I wanted to pop the value again, I just remove the first. So you can see a pattern here. If we use the push method in the stack, we just add the element in the beginning of the list, and then if I wanted to pop, I just remove the value in the beginning of the list. So that should give us a really good sense of how we would implement this using linked list. So now, since we have the values, the methods here, let's implement them one by one. So first of all, we have to use the linked list, right, to implement the stack. Therefore, we have to create an attribute here, and we'll call this list, and that will be a linked list using the type T, and we call this list. And when we instantiate this class, we'll say that linked will create a new list, and I think that's it. Now we have to implement each of these methods. So the easiest ones are, of course, size and isEmpty. So this we could implement really easily. Public int size. What is this? Well, if we wanted to get the size of the stack, we just need to return the size of the list, right? Because the list stores the value in the stack. So we just return list.size. And again, we already implemented this size method in the linked list, so it becomes really easy. The next one will be isEmpty. Boolean isEmpty. And again, we already implement this function, this method isEmpty in our linked list. So we just return list.isEmpty, and that's that. Now for push, pop and top. Now push, public void push t value. Whenever we push something into the list, into the stack, we want in our representation of the stack, which is the linked list, we want it to the upmost value in the stack to be the first value in the list. So what we do is just you take the value and we add it into the list. So the list dot, of course we need to add it in the beginning of the list. So for instance, if we add A has to be the first value, then B, then C, and then whenever we pop, we just remove the first element. So this will be list.add first value, and the method add first would take care of everything to increase the value of the list and everything, and of course adding the first value, into the list. And since we already added, I think there's not much we can do here. Now I think that's it. And then public for the next one, pop. Of course I have to return the value pop. And in here, if we want to return, of course we have to delete the first value. So how do we do this? Well, we just remove first, right? The method that we implemented in the, I think it was in the last, I think in the previous video. Well, so if we want to pop, we just, in this case, we remove the first element and then we return it. So what you do is just return list.remove first, and that's it pretty much. Then public t top. Well, this one you just need to return what? The first element in the list. And you do this by return list.get first. Well, it's pretty much it really. You just, since we added and since we implemented these methods in the linked list class, and it becomes really easy to just implement a stack using linked lists. So now I think since we are pretty much done, I think it'll be a good time for us to test the methods that we implemented. And of course, if you want to take a look at how the stack is doing when it comes to looking at the data, we can of course add a public string toString. And since we already implement this in the list, you just return list.toString. What you have to do is just to compile the code that we just wrote. That will be linked list stack, and see whether we have any errors at all. Okay, compiled. So now we have to, let's now create a file called test stack.java. And on this one, this is where we're going to call the various methods that we created. Then I'll create a stack. So now, since we created the stack interface, now we have to, the type of this thing, of course, will be stack. Then we'll have a type T, and then we'll call it S. And now, since we created a class which implements all these methods, we have to call it. So stack is just the interface which defines the type of the object. And now we have to call the actual class which implements the interface. So now I forgot something really important here, because this class of course has to implement the interface. So class linked list stack implements stack T, of course, and there's something really important and I shouldn't have forgotten. So now of course I have to use the linked list stack using time annotation again, and now we have our stack. What would happen if we added some values here? So let's add some. S dot push And of course, I can't use T here. I have to use something concrete. And in this case, I'll use, for instance, characters. Characters. It's in the singular. And I will push A, B, C, just to see what we get. A, B, C, D. So now let's take a look at let's take a look at our stack. Stem.out.println print line S. That should give us the representation. It should give us the representation of our stack. Let's compile this, test stack, and run. Yeah, I'm forgetting a lot of things here. On this video, it's complicated. New, of course, I have to instantiate the class linked list using the keyword new. Yeah, I forgot 1.0 in Boolean. Where was that? Yeah, in the interface. Let's try it again. Well, we have here our stack, and keep in mind that push since we use the upmost element in the stack as the first element in our linked list. Now you can just rotate this 90 degrees to the right, and you will have your stack, right? D is the upmost value in the stack, then C, then B, then A. If you wanted to pop the element, the upmost value from the stack, you would expect to print what? Of course, CBA, right? D will be removed. Okay, say that we want to print the size of the stack, and then we want to check whether if it's empty or not. Empty, it's a method, and that will be 3. 3, not 3. Jesus, I have something with trees today. I don't know what's going on. Then 3 false, of course. Of course, I could just continue popping s.pop. That would give me. Let's see what it gives me. That would be what? BA. Then I could pop again. That would give me only A. And then if I do it again, I would expect an empty stack. So that's what happened. So everything it's working as we intended it to, and so yeah, that's essentially how you implement stacks using linked lists. First, we created a stack interface with the methods underlying the functionalities of the type stack, and then we created a LinkedListStack class which implemented each one of those methods in the interface using linked lists. So yeah, I think that was it for this video, and we will use the next video to implement queues using linked lists, and I will try to tell you what queues are and give you a little brief on how they can be used and what they are. And after that, I will implement just like I did here with stack. I will implement a queue, creating an interface queue with type generic T, and then using linked lists to implement the queue. Alright, so I hope you enjoyed this video, and I hope you learned something from it, and yeah, I hope to see you on the next video.